All right, hello calculus. Welcome to your second and final, I believe, video for the week I'm gone here. Let's take a look. We are looking at your related rates packets. I think I have like 6 of them here, notes-wise. Again, we can talk about these when I get back. So funnel in the shape of an inverted cone. Again, that means a cone that's got the vertex down. Think about a little cup, a little water cup. Is 30 centimeters deep, that's the height, and its diameter across is 20, so the radius is 10. Liquid is flowing out, negative a derivative, 12. At what rate is the height of the liquid decreasing? So the height of the liquid is decreasing, so it better be a negative derivative. When it is, so when the height is 20, that's what I want. I want dH dt when the height is 20. Notice I give you nothing with, the rate at which the radius is decreasing is this. We can't solve for those two unknowns. So what we're going to do, if the radius is 10 and the height is 30, the radius is 1/3 the height. So instead of writing r squared, I'm going to write 1/3 height squared. Again, h squared times h, that's h to the third. 1/3 squared is 1/9. 1/9 times a third is 1/27, as I wrote right there. All right, so take the derivative of that formula. dv dt is equal to, I showed a bunch of work there. All right, just plug everything in and you're kind of on your own on that one right there, just getting the answer. We're going to have 400, you're going to divide by, then multiply by 9, divided by pi. Anyway, it's going to be negative. I think you guys can get that, help each other out. All right, the bottom of a rectangular swimming pool is that. Water is pumped into the tank, okay, at a rate of, that's dv dt, cubic, that's the third power. Find the rate at which the level of the water in the tank is rising. All right, now, so I want to find dH dt, okay. So volume is length times width times height, but folks, length times width is simply area. Volume is area times height. Now, that's the area of the base. That's what I mean, area of the base. The area of the base, folks, is constant. The area of the base, once it's full there, will always be 1,000. That's 40 times 25. Okay, so when I take the derivative here, the only thing that's changing is the volume and the height. The area is constantly, the area of the base, is constantly 1,000. dv dt is 1,000, dH dt, 500 is that, boom, there you go. All right, here is a balloon question. A balloon which always remains in a sphere is being inflated by pumping in that's dv dt, and it's positive. Find the rate at which the radius is increasing when it is 15. There's a formula, take the derivative, just plug everything in. That one's pretty self-explanatory. All right. Okay, I mentioned in the other video I did want to change. So, nope, not 21. We've already done 21. It was 24. All right. Okay, so same question, only I do want to change this to 450. That is for sure. We're going to change that to 450. So here's what's going on. Theta is on the ground here, all right? So we're going to just pretend that it's from the ground here. 450 up. Don't worry about the height of the observer. All right, I'll probably say on a quiz test that we're talking about the angle of elevation from the observer's feet. Okay, so what I want is the angle at which, or the rate at which this angle is increasing. All right, so I want d theta dt. All right, here's what I know. I know that tangent of theta is h over 450. That's the formula I'm going to use. I'm going to take the derivative. Derivative of tangent is secant squared theta d theta dt equals, again, this is just, h divided by 450 is 1/450 dH dt. Now, I did, to get d theta dt by itself, I just divided by secant squared theta. That's why that's there. dH dt is what, 120? They told us. Okay, so if you do this times 120, you get 120/450 divided by secant squared of, now how do I get pi over a fourth, or pi fourths there? Notice, folks, at that exact moment that we're evaluating everything, tangent would be 450. Tangent of theta would be 450 over 450, or tangent of theta would be 1, and that's when you have a 45-degree angle. So it is pi fourths. All right, so secant squared of pi fourths, I showed some work here. That's just 1 over cosine of pi fourths squared. So cosine of pi fourths is root 2 over 2, so 1 over that, that's the reciprocal, square both, you get 2, all right? So 2 is in that denominator, that's going to double the 450, that's how we get 120 over 900, and then radians per minute. All right, and then finally, got the last page here. Again, I might help you out with some questions on your homework. So again, try to get 10 to 13 of them done. The radius of a cylinder is increasing at that rate, but its total surface area remains constant. Interesting. At what rate is the height changing when the radius is 12? So surface area is that. The derivative of the surface area would be 0. It's not changing. What else do I know? I know dr dt is 5. There's a little drawing. So notice that this has nothing to do with volume. It's purely in terms of surface area. So surface area of a cylinder is this. I would give you that formula probably. Take the derivative. So this is definitely the product rule for this first one. Derivative of the first, 2 pi dr dt h, plus derivative of the second, 2 pi r dh dt, plus derivative, with respect to r right there, 4 pi r dr dt. All right, now, why did I put 0 here? Because d sa dt is 0. All right, that's the derivative, that's the rate of change for surface area. So plug everything in we know. We know dr dt is 5. How is that height? 64 over 3. We'll talk about that. How's the radius is 12. We know that. We need to figure out what dh dt is. We know 12. We know 5 for dr dt. Now, we need the heights, as you can see. We need the heights for that first part. So you just know that the surface area is 800 pi. You know the radius is 12. So you do a little bit of algebra to get 64 over 3 right there. That's how we know the height is 64 over 3. And, well, folks, just go from there, all right? Multiply this, add it to that, move it over. So if the radius is increasing, it makes sense that the height is decreasing if the surface area is remaining constant. So you get a negative, you're going to divide by, looks like 24 pi. The pi's will cancel, so just go from there. All right, this one does look like your homework 13, which I'm probably going to help you out with. Anyway, that is the tip of the shadow. These shadow questions are not very easy, that's for sure. A speed light is mounted at the top of a 20-foot pole. It's 20, it's remaining 20. A woman 5.5 feet tall is walking away from the pole with a speed of 6. All right, feet per second, dx dt we'll call it. It's positive because that distance is getting bigger. How fast is the tip of her shadow moving when she is 35 feet from the pole? That's the tip of the shadow when she's 35 feet away. So, using similar triangles, let's let x be the distance between the woman and the lamp. There's the lamp, there's the woman, x is the distance. All right, and that's, I mean, we want to put it there because, that we have a rate of change, dx dt, and that rate of change is exactly, we're evaluating exactly where that woman is. So, right there, she started, from there, and she's moving along there. So that's why we want the distance from the lamp to her to be x. All right, the distance between the tip of the shadow and the lamp, let's call that d. All right, and we want to find that derivative. So d, capital D dt. I know that sounds weird, but that's what we want to find. So using similar triangles, so this whole thing is d. That means this little portion right here, this smaller triangle, would be d minus x. All right, kind of like before we had 12 minus x on that one example. Using similar triangles, so I just set it up differently here. I did the height of the big guy over the height of the little guy is equal to the base of the big guy over the base of the little guy. right there. Now, I mean, we can cross multiply first to honestly get something that just has capital D in terms of x. I took the derivative, okay? That's we get that is equal to 20 dx dt. We know what dx dt is. Just divide, you'll get your answer there. And it's positive, all right? The tip of the shadow is moving away. All right, again, shadow problems aren't easy. Those are mostly homework questions for us here. A can is being filled with water, 8 centimeter radius. How fast does the height drop when the water is being drained? So negative derivative, remember dr dt for a cylinder that's not expanding or shrinking is 0. dv dt is negative 4.5. That's the formula for the volume of a cylinder. dv dt is equal to, take the derivative. Remember, I'm doing nothing with the derivative radius. I'm just plugging in 8 for the radius. This would be dh dt and whatever that is. So round it to however many decimal places. All right, folks, again, while I am gone, this is the last video other than maybe around Wednesday, hopefully. We can have a first video with our new co-star here, Elsie Mae. So as of this taping on Saturday, she's not here, but hopefully by Wednesday we'll have her ready for a video. The review homework 1 and 2, you need to pretty much finish that. Next week, we need to do as many homework questions from this packet as possible. We need to start reviewing for that quiz and that test. You got plenty of things to do while I'm gone. Please use that time wisely. Help each other out. And I'll see you soon. The Yakamath video, sign out.